Okay, here we go. So we are in that for relationships. This is our catch-up or check-up, whatever you want to call it, our fourth edition. So I'm going to go through these. These are examples very similar to the questions you will get. So we're going to go through all these examples and you're going to do the questions that are kind of a similar standard. So question one, what I'm going to need you to do is do some copying of if there's any diagram or any tables, you will need to copy these into your own jotters. So the first one is we're filling in the table for the graph of y equals 4x minus 1. So can you copy that equation of that straight line and then make a quick copy of this table? So x values 0, 1, 2, 3, 4, and then we're going to figure out the y values that match up with that. Okay, so take a wee minute just to copy in that information. Right, and this is the one where, remember, each set of x and y form a coordinate, which then we would draw onto a diagram. I'm not asking you to draw them though, I'm asking you just to, what is the y value and then what is the coordinate? So these values are x values, so we are substituting in these values for x and figuring out what that means for the y value. So if x equals 0, this equation becomes 4 times 0, take away 1. So 4 times 0 is 0, take away 1 is minus 1. So that then forms the coordinate, which I'd like you to write underneath, which is x, and then y, 0 minus 1. And that would be your first point that you would mark onto your graph. Okay, so when x is 1, what is the value of y? So 4 times 1 is 4, take away 1 is 3. So now we have the coordinate 1, 3. What is y when x is 2? 4 times 2 is 8. Take away 1 is 7. So that's going to be the point 2, 7. Write in the comments, what's the next point? What's the next y value? Don't have to write the coordinate point, just tell me what the next y value is. Please write it in the comments. Or say it. So substituting x equals 3. So yeah, I've got 11, 11, 11. That's right. So it's 4 times 3, which is 12. Take away 1, which is 11. So well done. So that forms the coordinate point 3, 11. And the last one is going to be 4 times 4. Take away 1. So that's 16. Take away 1. So that's 15. 4, 15. And you would use those points to match on your straight line, and you would connect that up if you were doing this in a... But we're not doing that. So that's fine. Next one is just an equation to solve. Okay, so question number 2, write it down with me. It's solve 4x plus 2 equals negative 6. Right, and this is so important, particularly for, if you are planning to go on to do National 5 next year, which some of us in here will definitely have those aspirations. Algebra work, equation work is so vital. So remember, you treat the equation as a balance. So whatever you do to the left side, you have to do to the right side of the equal sign. And to get rid of terms, you do the opposite thing. If it is adding, you take away. If it is a take away, you add, and so on. So the first thing I want to do is, what my ultimate goal is to get x on its own on the left. So the first thing I want to do is always, if there's something adding and subtracting, is always get rid of that first. So we've got a plus 2 here, which means to eliminate it, to get rid of it, I'm going to have to take away 2 from both sides. Be careful about what that leaves you on the right hand side. That is negative 6, take away another 2. So that's 2 steps further negative. So that's negative 8. Now I have 4x, I want to get 1x. My last step is always to do the division, which is in this case divide by 4. So it's x equals minus 8 divided by 4. So that's going to be negative 2. Alright, so that one's not too bad. I'm hoping that we would be okay with that. Question number 3 is a triangle. We have a right angle triangle and we have two sides given to us and we're trying to find third side. Now, we have done 2 bits of maths to do with triangles. One of them is trig, one of them is Pythagoras. Can you write in the comments, is this a trigonometry question or is this a Pythagoras theorem question? What do you think? Trig or Pythagoras? Okay, you're all telling me trig. Okay, so in order for me to solve any trig question, I need to know at least one side and I need to know at least one of these angles in the corners. I have no angles, therefore it is not trig, it is Pythagoras. I'm not dealing with any angles here, I'm not looking for an angle. All I'm trying to do is find a missing side when I have the 2 other sides. That is Pythagoras. So this is really key for us, is being able to recognise which one is trig and which one is Pythagoras. So if there are no angles involved, maybe you want to write this in your jotter, if there are no angles involved, then it means it is Pythagoras. Pythagoras only deals with the 3 sides of a right angle triangle. So look at your triangle. Obviously we've got that 90-degree angle in there, but that's never the one that we work with. Okay, so if there's no angles in either of those 2 other corners, then it is Pythagoras. Okay, so in this case, Pythagoras, we need to label a triangle. Remember, we don't label it hypotenuse, opposite and adjacent because there's no angles, but we do label it the hypotenuse with the letter C, and our 2 smaller sides are A and B. So A I always call the missing side and B is the other smaller side. Okay, so if you've drawn that triangle, you've labelled it A, B and C. We are looking for a smaller side here, therefore we use Pythagoras theorem for a smaller side, which is A squared equals C squared subtract B squared. Okay, not adding, we are subtracting when we're finding a smaller side. Bigger one squared, take away the smaller one squared. Right, you will need a calculator handy. So A squared is equal to 6 squared, take away 4 squared. So can you do in a calculator? Now some of you might be able to do that, should be able to do that in your head. 6 squared, 6 times 6, take away 4 squared, 4 times 4. But you will always have a calculator, so let's maybe practice for Nat 5 to not use a calculator. 6 squared is 36, take away 4 squared, which is 16. So 36 minus 16, that's going to be 20. Okay, but remember, this isn't as finished because I don't have A, I have A squared right now. So to get the missing side A, I have to undo the squared by taking the square root of both sides. So my final line of working is going to be to do the square root of your answer from the first bit. Square root of 20, which is going to be 4.472, which, just to tidy it up a bit, we'll round to 1 decimal place. 4.5 centimetres. That's to 1 decimal place. Okay, so 2 parts there. First of all, recognising whether it's trig or Pythagoras. If there's no angles in the corners, it's Pythagoras. If you're asked anything to do with an angle, it has to be trig. Okay, then it's remembering this starting point for your missing side in a Pythagoras triangle. A squared equals C squared minus B squared. If you manage to get that far, you should be okay with the rest. Right. Next question then. Or does anyone have any questions about any of those 3? The straight line equation, Pythagoras? No? Okay. Right, question number 4 is going to be slightly difficult for you to draw if you don't have squared paper. But we've got a shape and we're trying to enlarge it by a factor of 3. So what you can maybe do is just, if you're able to draw this with a ruler or something, some sort of straight edge, a book edge, a textbook edge, or a phone cover edge or something like that is a straight edge, and maybe just mark on how many boxes it is for each one. So it's 3, 3, that's 2 up there, that's 2 up there, and then there's a slanty line. Okay, so draw that as as neatly as accurate as you can. If you've got a ruler, you can maybe do it 3 centimeters, 3 centimeters, 2 centimeters. Enlarge it by a factor of 3. Now, this is straightforward enough. If we're enlarging it by a factor, all you do is you multiply each side by that factor. So remember, we did this with fractions. We were multiplying by like a half or multiplying by 1.5, 3 over 2. But in this case, it's a lot simpler. We're just multiplying everything by 3. So along the bottom, that new horizontal kind of line at the bottom is going to go from 3 to 9. So it's going to be 3 times 3. That's going to be 9 boxes along the bottom. So I can start by drawing a line that's approximately 3 times as big. So I'm going to try and do as best I can to 9 boxes. That's not a black line. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we know also that that is going to be 3 times 3, that's going to be 9 boxes high. Now, do I even have 9 boxes? 1, 2, 3. Oh, I need to move my line down 1 in order to fit this in. Right, so it's going to be 9 boxes high as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll just pretend that there's a line there. Okay, and you can do this kind of in any order you want. That you do need to show these calculations though, that you've multiplied the sides by that scale factor, whatever it is. Usually it would be a fraction. 2 times 3 is 6 boxes, so I need to go along 6 boxes and I need to go up 6 boxes. So I'll go up 6 first. So 1, 2, 3, 4, 5, 6, and I'll go along 6, and then I just need to join up the dots for the slanted bit. No, it's not letting me draw it. 1, 2, 3, 4, 5, 6, and then let's connect those lines. So you'd mark on that is now 9 boxes, that's 6, that's 6. Okay, and that's you enlarge that shape. Okay, so that one's kind of hard to do if you don't have squared paper, so just need to do your best with that really just now. Change the subject of a formula to h. So the next question we have y equals h plus 8, and it's kind of similar to solving the equation. I need to get my h on its own on the left. That's how we turn another variable into the subject of the formula, as we get it so that it is on the left hand side of the equal sign and then it's on its own, there's nothing else with it. So remember, this is quite a straightforward example, this one. If the thing we want to make the subject, which is h, if it's not on the left, we just flip it round first. So we've got h plus 8 equals y. We just completely flip the equation round. Now we're thinking about our solving equation rules. I want to get h on its own, which means I want to get rid of this positive 8. The way I would do that is by taking away 8 from both sides. Okay, so if I do that, try and get rid of this slightly. So if I do that, I'm going to get h equals y, take away 8. And that is my final answer. H is now on its own on the left hand side. I think that one should be okay for us. Calculate the size of the angle marked X. Now, you may want to draw just a quick circle and a triangle inside it. Now, there was a specific rule for one of the angles in this triangle. It is this one in the corner, which I'm going to put a dot in. That's all. That kind of angle is always the same size. Can you write down in the comments, please, what size that angle is? So that's when you have two lines meeting on the edge of a semicircle from a diameter. What does that always form? Yeah, it always forms a 90-degree angle. Well done, guys. Yeah, so we can, in your drawing, you can maybe do your little kind of box to show that that's a 90-degree angle. So to find our missing angle, well, we know that the three angles in a triangle, the other rule we need is that the three angles in a triangle add up to 180. So to get x, we just do 180 minus the 90 minus the other angle as well. So that is just 90 minus 57. So write down your answer, please. And I would like to see some of us trying this non-calculator. It is, yeah, 33 degrees. Remember your degree sign, please. Okay, 180 minus 90 minus 57. You can just throw that in your calculator if you prefer, but I do want you to try and, work on your numeracy work, trying to do stuff in your head. Okay, that's question 6 done. Now we're moving on again. Am I going too fast or am I okay? Anyone leave me a comment if you want me to slow down. I think we're okay. Alright, we'll crack on then. Thanks, Molly. Okay, next one is one of these angle ones where we've got a whole load of different angles going on. Parallel lines, triangles, opposite angles, supplementary angles, Travis. And we need to figure out, we need to just try and kind of work our way towards our shaded angle here and figure out what that is. Okay, so you're thinking about all your angle rules. The most common one is the supplementary rule, which is angles that are intersected by a straight line. They form 180 degrees. Now, I don't know what's best for you to actually, if you're fine to just draw this, you can. You don't actually need to put in all the letters, but if you can draw me just two parallel lines and it's just basically like a V cutting through it, and mark on the two numbers there. You don't need all the letters, right? So you've got your supplementary rule, which is a straight line cut between 180 degrees. You have your angles opposite across that are always the same. So those angles opposite across are always the same. We have the three angles in a triangle add up to 180. You're also looking out for any Z angles in this case. So if we have two parallel lines, our angles in the corners are always the same. So the angle in that corner is the same as the angle in that corner. You're also looking out for, do we have any F angles? So if you have one straight line with two parallel lines kind of cutting it, then the angles in the inside kind of corners match up. So that matches up with that. So these are all the angle rules, plus your three angles in a triangle adding up to 180. That's the kind of rules that we need to be remembering here. Okay, so we're trying to find this grey angle. So we know that actually that's a straight line all the way across. So these three are all going to add up to 180 degrees. So if I knew this one in here, I'd be able to take these two away from 180 and get that grey one. So I'm maybe thinking that I'm going to try and get this one in here. Another way I could get my grey angle is if I knew these two in the corners, I could take those away from 180 and get there. There's more than one way to get to the final answer, is what I'm trying to say. Okay, I think the most obvious place to start is showing that that is opposite across. So F will also be 135 degrees. What we're able to do now, and we actually could have done that from the start, is we have a supplementary angle actually in both directions. kind of horizontally and diagonally, they're both 135. They're both meeting this top left corner angle in a supplementary angle. So wee bit of working at the side, 180 minus 135. So what is that angle going to be? So 180 take away 135, that's going to be 55 degrees. No, it's not. It's going to be 45 degrees. (180 minus 135), 45 degrees. Yeah, so that's 45 degrees in here. Now, if you can spot it, we have like a backwards Z situation on the go. So if I draw my Z here, so that's two parallel lines split by a line through the middle. So that means that 45 degrees is actually exactly the same angle as this 45 degrees down here. Okay, so using this Z parallel alternate angle rule. So now that means that to find this grey angle, I know that the three of these add up to give 180 degrees. So I can actually find the grey angle by doing 180 grey angle or shaded angle, 180 minus 45 minus 45. So that's actually 180 minus 90. So that's just actually 90 degrees, that angle. And that's my final answer. Hope we're okay with that one. You just you can play about with that in any way you want. It's just finding the easiest way to get to the final answer. There's more than one way to get there. Okay, I've got one more slide. I know this has been quite a long time in the call. I've got one more slide to show you, and then we're done. So, two more triangles. We have clarified already how to figure out if they are trig or Pythagoras. They are right angle triangles. However, I have angles in the corner to deal with. Therefore, I know that it's trig. So I need you to draw both of these triangles just now, quickly. And I'll write down this up here. If there are angles, why can I not spell angles? If there are angles involved, then it means it is trigonometry. So that is SOHCAHTOA. Okay, so this is what we've been doing for the last how many weeks? Feels like forever, I know. Sketching the triangle, labeling it, hypotenuse, opposite, adjacent, using SOHCAHTOA, and figuring out either the side or the angle. Okay, so we should have no problems with these two because we've been doing these the most recently. So if we look at the first one and start to label it, the 16 is going to be the hypotenuse. Stand on your angle, go opposite side is down here, and then next to the angle is the side x, the adjacent. Okay, so in the first one, SOHCAHTOA. Okay, I'm not interested in the opposite side, so I should not be ticking the opposite here. I have the hypotenuse and I'm trying to find the adjacent side. So which one has two ticks? It's going to be C. So it is the cosine ratio. So it is the cosine of 40 degrees is equal to A over H, A over H. So it is the cosine of 40 degrees equal to the adjacent side, which is the missing one, x, over the hypotenuse side, which is 16. Now I'm going to let you finish this off. Type in your answer when you have one, please. Rounded to 1 decimal place. So finish off this, rearrange it slightly, and give me your answer when you've got it. Okay, thank you, Sam. Anyone else got an answer yet? Okay, all get the same answer, and this time you are all correct, yes. So we should have done, we take that 16 and we multiply it up on this side. So whatever the denominator is, that's the process, equals x. So x, when you type 16 times cos of 40, you get 12.256. And yeah, when we round that to one decimal place, we round that to, it goes up because it's got a 5 to the right of it, so it's 12.3 centimetres. So yes, well done if you got that, good job. Last one, guys, and then I'll let you crack on, is this one here. So draw me another triangle. This time we have two sides and we're looking to find the missing angle. Okay, so if you've already drawn the triangle, you can start to label it. So we have opposite our right angle is the hypotenuse. Now stand at your missing angle in the corner, go across the way, across to the other side, and that is the opposite side. And the side that is right next to the angle is the adjacent side. Okay, so be very careful, make sure you've labelled it correctly before moving on. So katoa. Right, what have we got? We've got the hypotenuse, and we have the opposite side. So 2 ticks is S this time, which is the sine ratio. So it's the sine of the angle, which is just x, and it's OH, opposite over hypotenuse. So it is the sine of x, opposite side. Remember, make sure you don't get these the wrong way around. So just double check your diagram. The opposite is definitely the 9. The hypotenuse is the 16. I'm not going to tell you how to finish this off for the angle. Remember the slightly different process. What do I do next? Finish it off. Write down your answer, please, to one decimal place. Okay, thank you, Sam. Thank you, Travis. Anyone else get an answer? 34.2, 34.2. Yeah, we're all getting the same thing. Now, remember, this is the angle we're finding, so my units isn't centimetres, but just that's only a wee thing. So, well done for getting the right number, though. We do the inverse of sine of the fraction. So, it's the inverse of sine of the fraction, and yeah, we get that angle to be 34.22228, and that is then 34.2 degrees as your unit. So yeah, well done to those that gave me that answer there. I hope the rest of us were able to do that inverse sine okay. If you got a totally different answer, make sure you're not in radians, make sure you have that degrees button ticked. Okay, so that's pretty much it. That's just a quick recap of, obviously not in full the whole course, but the main kind of fundamentals of each topic. So what I'm going to do now is if there's any questions, I'll answer them, but I'm cautious of time. I'm going to let you get started on your quiz, and you've got 15 minutes, which might be enough time. I would like you to try and finish this, for the next time you're in maths. So you've got 2 days, but ideally just, try and finish it today. If you don't get all the questions done before your next class, if you just leave it open and maybe spend 10 minutes at the end of the day finishing it off. Okay, it's not huge, it's just the same number of questions we just had, I think, so it shouldn't take you long. Okay, if there's no questions, then I'll let you crack on with that. I'll post the form just now, and thanks to you guys for joining in. And I'll see you again on Thursday. Okay, bye for now.
Bye.